Let's go ahead and talk databases, specifically relational databases first. So Amazon has a relational database service. So go ahead and watch this video first to introduce this module. Once you're ready to continue, let's go ahead and define some key terms. So what is a database? I know we've mentioned it before, but we're going to take a little bit of a closer look at them. I even have an assignment where you get to interact with a database online. So let's go ahead and define that. So a database, often called or referred to as a DB, is an organized collection of data that allows users to store, retrieve, manage, and manipulate information efficiently. So it's all about not only storing data, but also retrieving it really quickly. We often call the data in a database, we call them records. So if you're thinking customer records, right, student records, those are all probably going to be organized in a database. So it supports data retrieval using queries. There's specialized languages and structures for making queries to these databases. It can be managed using a DBMS or database management system. Some popular ones are like PostgreSQL, MySQL. You probably heard all these different SQL names. Those are just the ones that manage a database. It's just a system for managing a particular type of database. So it's used in applications like websites, banking, and cloud storage. If you're a serious application, if you're doing some serious computing, whether you're running an app or an e-commerce website, chances are 90 something percent chance is that you're going to have some kind of database. Very few enterprise applications are going to be working without databases these days. Because of course, right, you rely heavily on your users' data, on collecting data on their activity and so forth to make these applications work. For example, like users logging in right to your application, you got to have a database having all their credentials in order to make that possible. So when data is in a database is structured or organized, so we're using the word structured a lot, that just means organized. When you organize it into a table, this particular category of databases is called relational databases. The only thing special about them is that they use tables to organize the data, which kind of makes sense, right? If you ever looked at a spreadsheet, that's a table. Well, relational databases organize it in a very similar fashion, rows and columns. So when a DB does not structure data into tables, it's usually classified as a non-relational database. So what is a relational database? We actually call them SQL databases. I'll explain that in a sec. So stores data in structured tables with rows and columns, enforcing relationships between them through keys. So every row is going to be a record in the database. Every column is usually going to be some kind of attribute. So for example, a row might be a student, right? We have a student row. Let's actually go here. So we have a student row. And then the columns might be the student's name, the student's ID number. Actually, ID number should go at the front, right? With any database, there's got to be a unique identifier. We've already talked about keys with object storage. Just generally in computing, when we're dealing with data, it's nice to have a unique identifier so we can distinguish data from one another. So yeah, relational database has IDs, has rows, has columns. It's basically a table. The ID column is a kind of an important one. Otherwise, it's hard to distinguish, right? The unique sets of data. So why are they called SQL databases? Because they use a special language called the structured query language. So that's the language they use for queries, for putting things in the database, retrieving them, deleting them, updating them, etc. So some examples of relational database systems are MySQL, PostgreSQL, and of course, Amazon RDS. That's going to help you manage a relational database in the cloud. So again, this is what they might look like. This is the tabular format. This is how it's structured or organized. Going back to the coffee example, right? So if you're running your coffee shop, you might have a database on your different products, the sizes available, and the price. And of course, a lot of these databases handle this part automatically. It'll assign a unique ID to each record or each row in your database. So what is Amazon RDS? Let's go ahead and describe that unique AWS service solution for database, specifically relational databases. Remember, often called SQL databases. So it's a service that enables you to run relational databases in the AWS cloud. So automated management, so handles the hardware. Remember, that's kind of the big selling points of cloud compute, is that they're going to handle all the hardware stuff for you. You don't have to actually set up any hardware yourself, do any on-premises stuff. They're going to do it for you. And then it's going to do database setup, backups, patching, and maintenance. It does a lot of things for you. So it makes really hosting a database really easy. Of course, it's scalable. So if you need to double, triple, 10x the size of that database, Amazon's got your back, right? Unlimited size. High availability. So it's going to support multi AZ deployments. So remember, redundancy in case there's failures. Your data is always going to be available. From the point of view of your customers, there should be almost no interruptions. There's always cases, right, where interruptions do happen, but for the most part, AWS does work to prevent that. And of course, all the security tools, encryption, network isolation, and IAM based access control. So remember the user and group roles we set up in the first lab. You can actually set up access to these databases based on those users and groups. So Amazon RDS. So it's available on several database engines. So there are many different types of database engines out there. So if you started, building your database in MySQL or PostgreSQL or Oracle, Amazon RDS will manage any of those types. Here are some of the ones that they do support: MySQL, Postgres, MariaDB, Oracle, Microsoft SQL Server, Amazon Aurora. Personally, I've only used MySQL and Postgres in my job and in my academic career. There's so many different like flavors of databases out there. The two main categories though we'll learn are SQL databases, the relational ones, and then the non-SQL or non-relational, which we're going to cover shortly. And then they even have their own in-house service called Amazon Aurora, so their own flavor of cloud optimized databases. So Amazon Aurora, it's AWS cloud optimized, specifically made to be used on the cloud. It's high performance, designed for speed, availability, and scalability. It's compatible with MySQL and PostgreSQL, right? Some of the way popular ones. Like I said, only the two that I've used. It is 5 times faster than standard MySQL databases and up to 3 times faster than standard PostgreSQL databases. So again, it's optimized for the cloud. It's going to deliver you some really, really top speeds. It's going to help reduce costs by reducing unnecessary I/O operations while ensuring that your database resources remain reliable and available. So it is cloud optimized, so not just optimized in performance, but also in cost. So it's great for workloads that require high availability, replicates 6 copies of your data across 3 AZs, and it continuously backs up your data to Amazon S3. So everything's going to be, it's going to have backup copies of your databases in S3 buckets. So very, very cool. Lots of great features. Make sure. I think I might double up on that slide. Next up, we'll cover some of the different types of AWS database services, and we'll talk about NoSQL or non-relational databases.